As part of our continued commitment to improving the quality and performance of Bryant HVAC systems, I'm going to show you how to measure and calculate system airflow, or CFM. This video will cover taking the measurements. In a second video, we will show you how to use these measurements to calculate the CFM. You can measure airflow in a system several ways. This video will cover the technique of measuring the velocity pressure in a duct system. It is important to understand that the indoor furnace or fan coil equipment is an air-moving device. Fundamentally, the air entering the device will be the same amount of air leaving the device. This video is a simplification of one method shown in the service training program, Air Properties and Measurement, available from the Bynum Training Center. To measure airflow, you will need the following tools: a Pitot tube, a magnehelic, or inclined or digital manometer with a resolution from 0 to 0.1 inches of water column. A 0 to 1 inch water column manometer may be used, a thermometer, a tape measure, a calculator, and a pad of paper. Airflow is measured in CFM, which stands for cubic feet per minute. CFM is equal to the inside area of the duct in square feet and the velocity of the air in feet per minute. When multiplied together, the result is cubic feet per minute. Accurate airflow measurement requires the velocity readings to be taken in multiple places in the same cross-sectional area of the duct. This is because the velocity profile in the duct is slightly different in each part of the duct. For a rectangular duct, you should take at least 6 readings. And for round ducts, check the table of distances as shown in the Air Properties and Management materials. As a quick test, you can also take one reading in the center of the duct, known as the single point approximation. However, you must multiply the velocity reading by 0.9. It is important to take the velocity readings in a straight section of duct before any elbows or takeoff. The ideal location in many furnaces and fan coils is the return air duct right before the return air boot. If the return is a box connected to the furnace with branch returns, you can measure each branch return and add the results together to achieve the total CFM. Measure and mark the duct to locate the points where the Pitot tube will be inserted to measure the airflow. If you're inserting the probe on the narrow side of the duct, locate 2 holes evenly spaced on the duct. If you're inserting the Pitot tube from the wide side of the duct, locate 3 evenly spaced holes on the side of the duct. It may help to draw the points out on a piece of paper first. Drill a small hole at the marked locations so you can insert the Pitot tube and thermometer. For this example, we are using a 10 by 20 inch return duct. We marked our Pitot tube depth locations to simplify taking readings. We are using the narrow side of the duct and marked the Pitot tube at 5, 10, and 15 inches. If we used the wide side of the duct, we would have marked the location at 2.5 and 7.5 inches. For a more detailed explanation, refer to Air Properties and Measurement materials. When you take multiple readings, it is helpful to set up a data table as shown. Also, when checking the cooling airflow outside of the normal cooling season, turn off the outdoor unit either at the breaker panel or the unit's disconnect panel. This will prevent the unit from starting and possibly slugging the compressor. To begin taking your readings, it is best to start with the system in the cooling mode. Record your readings in the cooling mode, and then do the same for each stage of the heating mode. This way, you get a true picture of the equipment's airflow performance. Connect the Pitot tube to your manometer or magnehelic. There are 2 sets of holes on the end of the Pitot tube, a total pressure hole at the tip of the probe, and 8 holes for static pressure. When connected as shown, the reading on your manometer will be the velocity pressure. Note that if you're using a magnehelic, it will have high and low ports. Set the equipment to call for cooling at the thermostat. On zone systems, open all zones and close the bypass duct. Let the blower run for at least 5 minutes to allow the airflow in the system to stabilize. Insert the pitot tube into the hole in the duct. Make sure the pitot tube is level and the port is pointing up as you take each reading. Record each pitot tube reading on your data sheet. It doesn't hurt to take the time to take a second set of measurements to compare to your first set of measurements. Be careful to record all your readings accurately into your table. Now measure and record the temperature of the air in the duct system. We will explain why this is necessary in our next video, calculating CFM. To get a complete picture of the unit's airflow, you can repeat this process in both high stage heat, then low stage heat. Following the simple best practices demonstrated in this video will help you take the measurements you need to calculate the airflow of a system. In part 2 of this video, calculating CFM, we will walk you through the calculations needed to determine the CFM of the system. Thanks for watching Tech Tips.